Recording. Okay, it says, guess it is recording. Okay, let's go with it. So class, here it is. Welcome to chapter 8. It is going to be exactly or very, very, very close to chapter 7 in as far as what we're going to cover here. The only thing is, instead of having one population group that we're dealing with, we're going to deal with two. Good there? So here it is. Here is hypothesis testing. I think it's chapter 7. So you have now two samples. So how do you know if, I don't know, one statistics class, right, had a better grade on their final than another statistics class, right? That's kind of what we're looking at. Or even better yet, as we're going to do the example here, how do you know if a state testing in the state of Chicago for some reason, right? If one teacher does the exact same lesson and another teacher does the exact same lesson, see if are the scores different of the students, right? That's kind of what we're dealing with. More importantly, how about I don't know, heart rate medication, right? You have a population group and then you have another population group and then you try to compare them, right? So it's the stuff we started off a long time ago with, remember the placebo effect, right? We're going to actually do an experiment, have two different populations. One is taking the medication, one is taking the placebo, and then we'll see what happens. So this chapter 8, I think, is like really cool. It's really finally getting to what we really do in stats. We're good? So let's jam. The only thing, here's my little caveat for chapter 8. The formulas are big. We're good. So we're not going to do a lot of them. We're probably just going to do like one problem per section. How about that? Right? We'll introduce it, one problem, and then we'll kind of get a handle of it here. So first things first, we've got to do one thing we have to understand is this something called independent samples and dependent samples. So let's take a look at what we're going to do in chapter 8. So it is about means. So remember chapter 7 was about means as well, right? And we did a z-score if we know the population standard deviation, right? Then we're going to go over here. We're going to go to what happens if we don't know the population standard deviation. I think it's called a t-value. Remember that? Little t-tables that we did? And then we have the difference between something called dependent sample. So let's talk about this here. So independent sample and a dependent sample. Those are things we have to keep in mind. So let's talk about it, and then we'll kind of judge it. So as you read the problem, there's going to be something that's going to say like, oh, that is a dependent sample. Oh, that's an independent sample. And the formulas are really, really different from one another. Okay, good, there. So if you guys want to do, so 8.1, it's a long title here, testing the difference between means. So a few things here, independent samples. And then notice that you got a little subscript. It's the standard deviation 1 and standard deviation 2 are known. So introduce it, talk about it, and we'll do one example with it. I'll give you the formula for it, and then we'll do one example of it. All right, so let's see. And I will keep on going. And you tell me if I went a little too fast, then I will come back on the slide. Got a few people still writing. Absolutely, I'll wait, and then we'll go from there. Cool, yeah, just kind of keep in mind here. So testing difference of means, independent samples, and then the population standard deviations are known. Okay, so let's talk about it. Independent versus dependent samples here. And I'm going to just kind of jump. I guess I can just jump around. This will probably be the best illustration here. So independent samples means this. You got to sample 1 and you got to sample 2. Notice first of all, and these guys are individual samples. We're good. So notice first of all, the numbers are not the same. How many we have here? 4. This one, 1, 2, 3, 4, 5, 6. There's 7 here, right? So notice we're just randomly picking some samples here, randomly picking some samples. They could also be the same. There could have been 7 here and 7 here. Here's the thing. is they're not connected to each other. Okay. So one way that you can connect samples is have the same person. This is like before something has happened and after something has happened. The same person has been breathing. Good. Another way you can connect it, let's say we are doing a study whether, I don't know, a certain educational program is good. We're good? So what we do is we're going to line up the students, like that's the 4.0 student and that's the 4.0 student. We're good? That's the 3.7 student, that's the 3.7 student. Notice we line up the people to each other so that we have as close as possible. Okay, a good way example would be more like this. If you're giving heart medication to people, you're not just going to arbitrarily give it. Maybe what you do is you say, hey, look, how about the person that is fit and jogs 5 miles a day? That should be kind of toned with the other person that is fit and jogs 5 miles a day, right? And the guy that's just sitting in the office 8 hours a day and the other guy that's sitting in the office 8 hours a day. So you kind of match them up as much as possible. Good. That's what you're going to do. So there's some kind of matching, or if they're talking with the same exact person, doing it before and after, that's what you're talking about. And examples. Okay, we're good there. So let's jump now. Let's go without writing anything down. Talk to me here. Tell me if this is independent or dependent. Don't need to write it down. Now let's talk about it here. Go. So we have sample one, right, which is the first sample, right? So we have triglyceride levels of 70 patients. We wait 6 months. They're on this lowering drug, and we test the same exact people again. Dependent or independent? Dependent. Absolutely. It's the same exact person. We tested twice, right? So yeah, absolutely dependent. And then the other one. Notice when the numbers are off, you know absolutely they're independent right away, right? If the numbers are the same, then you got to test whether they connected each individual person. Okay, so that would be independent here. Okay, so let's go with it here. So first things first, we're going to do is let's talk about the null hypothesis and the alternative. How has it changed from chapter 7? So first things first, if you want to write these down, it's going to go like this. Here are your three choices. So the two sample hypothesis testings are these. So the null hypothesis, notice you got a mu1 and a mu2 now. You got two of these guys. It's kind of interesting the way we actually still do it. All right, so it could be that you're talking, the claim is this. Could be that the claim is that mu1 is less than or equal to mu2. It could be the claim is that mu1 is less than mu2. So notice the very top, it always somehow has an equal sign somewhere there. On the bottom, there's no equal sign. Actually, the equal sign is rejected on the first one, has a greater than symbol for the second one, a less than symbol for the third one. Would be the three options we have. And they will also have to put a claim in there somewhere. Is that right? Sometimes it's null hypothesis, sometimes it's the alternative hypothesis. All right, and the bottom, you can kind of highlight maybe just a couple of things here. This around. Let's see where can I put this. All right, just assume, there it is. How about assume this to be true? Assume that when we do this stuff, we're going to assume this to be true. And we'll see it by the formula. Again, formulas are huge. That's okay. We'll just work through one of them. This is kind of cool because finally getting to the place where actually we're juiced up with stats here. Okay, just if you want to write the whole entire English sentence, that's fine. But if you just want to say it's just assume that to be true, just the highlighted stuff, that's fine too. Assume that to be true. So again, regardless of which hypothesis test you're using, regardless of where the claim is, we just assume that to be true. So really what we do is instead of two sample, we're kind of just trying to figure out how to make it into a one sample. That's kind of what we do as far as our equation goes. That's all right. Are we good to go? Next on the list here, probably don't need to write down all of that. Oh, sorry. I am going a little great. That's what I want to go. Okay, that was the next slide here. If you want to write down all of this, that's fine too, but I want you guys to write down the formula. It looks huge. I understand. It's okay. So let me highlight. That's kind of what I want you guys to. You want to do the other stuff on top. Again, you guys do have these slides, bless you. You do have these slides on Canvas as well. So if you want to ever go back to them. So here's the check mark here. So you know standard deviation of 1, standard deviation of 2. And somehow you know that the samples are random. And the samples are independent. Make sure these guys are independent. And then also that each of them are above 30, which allows you to have a normal distribution. Those 4 items are true. That's the humongous formula. We're only going to write it once. Good. Formula there. And making you write a lot here. Okay, that's done. Everything else remains the same. We're good. So this is just chapter 7 all over again. The process still remains the same, just a different form. So let's go with one example here. Oh, go for it. Got a couple of people still writing things down. Go for it. Cool. All right, let's go with it here. So, all right, so let's see. So one example here, we can go with it. So we have a credit counseling group, credit Watchdog group here claims that there's a difference in the average credit card debts and households between California and Florida. So maybe credit card companies are targeting California because the pay is higher. I'm not sure. Like, okay, so is it or is it not here? So is there a difference between, or the Watchdog group claims that there is a difference between debts, credit card debts and households in California and Florida. Good. So we'll go with that. So the results of the survey from 250 households from each state. So there's 250 there and 250 there. The two samples are independent. That's cool. So there's no dependency on, we didn't adjust for like how much people made, right? We just randomly picked people. So the standard deviation of the first one is 960 for California, 845 for Florida. That's cool. Again, it's independent. That's what I'm interested in right here. So the question is, does that support the claim? So if you want to write down at least the information from here, put CA for California, you can put X1 bar is 3,060 average credit card debt. N1, there's 250 people or households that were included. Florida debt is 2910 with the same amount of people. And then if you want to, you can bring this down. Alpha level is 0.05. That's the other little piece of information we need right here. Okay, from that, can you guys write for me the HO and HA? I'll give it to you on the next slide here, but can you guys give me what's the null hypothesis and what is the alternative hypothesis? Don't have my pin with me. Oh, I don't have my pin with me, so I have to rely on this guy here. So this is not going to look that good, but I'll try my best here. So boom, HO, HA. I'm gonna go like this probably, right? It does these weird symbols here. Sorry guys, does some weird stuff like that. So this is mu1 and mu2. And the null hypothesis, that means that they're equal to each other. mu1 does not equal mu2. And which one's the claim? I'm thinking this one's the claim, is that right? So the first sentence is the watchdog group claims that there is a difference between the debt in both states. Okay, next, two-tail test, left-tail test, or right-tail test? Oh, honesty question as well. How many of you guys looked at, just kind of skim through chapter 8, just to sort of, hey, what am I going to see here today? Okay. All right, so you guys talk to me here. So I have an alpha level 0.05. Oh, sorry, two-tailed or one-tailed? What do you guys say? It's a two-tailed test, right? If there means that there's a difference, because the difference could be bigger or smaller. It doesn't matter the difference. Okay, cool. And then you can start drawing this already here as well. Draw this. You can draw this right here like this. And then I need to know what is my, so I'm going to put that right here like this. I'm going to put this right here too. And I need to know this value right here. I need to know my negative z naught value, and I need to know my positive z naught value. Understanding that I have a alpha level 0.05. Help me out on that. Which one is that? What is it going to be? Ouch. Anybody see people already looking at their table? So go for it. You got your table here. The two-tailed test, alpha level 0.05. I need to know what is my Z naught values, negative and positive. So if it's a two-tailed test, remember your alpha level is going to be half. Is that right? Alpha divided by 2 over here. So I'm looking for a 0.025 on this side, right? And I'm looking for a 0.025 on this side. I don't care about that side as much because that's the one I want to worry about. So that's the one that's going to be on my chart, right? So give me a 0.025 area. So you just need to find one of them, not both of them. So it's going to be on the front cover or the front page. And you're looking for the negative z-score because the positive is going to be exactly the same, right? And 1.96, I'm going to go with that. So everybody okay with a negative 1.96 here and a 1.96 over here? Okay, we're good there. So what did you see on the chart here? Was it a 0.0250 right, on the chart? Chase? Cool, okay. Perfect, okay. Are we good there? Ready to go on? Okay, so all the steps. Notice the same steps as chapter 7, right? You're finding this, you find the alpha level, you find your Z naught score, you write down your claim and your null and alternative hypotheses. Okay, perfect. Okay, now let's get to the math. Sorry, I just don't have my pen with me or else it will look a lot better. Having to do this by mouse. Okay, got a few people. So this would be alpha. This is alpha divided by 2 since it's a two-tail test. And because of that, alpha level is 0.025. And on the little chart that we use, there are always 4 decimal places accuracy. So you're looking for this guy on the chart. And we got a negative 1.96. Look at it yourself, see if you guys get it. Cool. Okay, so now let's put in some numbers here. So that formula that we just did a little while back, let's go for it here. We're going to plug into the formula. That's my formula. Again, it's huge, but once we're done, we're done. So we're going to go with, that's the formula that we just did from the other side. And it was kind of like in 2 parts when we did the formula itself. That was just one big part here. So it is the difference. So notice a few little things here. Notice this little piece right here. That's just going to be 0 right there. So as you write it out, try this on your calculator as well here. So this is the standard deviation of 1 squared divided by the number of people in sample 1. All right, and once you write it down, try it on your calculator to see if you guys get a 1.85. Go for it, try it on your calculator after you write it down. So notice that assumption of mu1 and mu2 are equal to each other. Therefore, if they are equal to each other, that means there's no difference between the two. All right, we're doing 8.1, and we're just getting into the heavy duty math stuff of it. So if you guys can write down the formula, because the formula is right there, punch in the numbers, and then try it on the calculator to see if you guys get the same number. Give you guys about a minute or so, or maybe a little bit more. Let's see if you guys can punch it in and tell me if you guys. I'm gonna try this ball here. So let's put this together here and see if we get. Let's see if I can guide some of it here. Okay, I got my first parenthesis, just exactly what it says on top, divide by, and it's gonna be a square root. 60 squared divided by 250 plus 845 squared divided by 250. Okay. Oh yeah. Okay. Mine worked just perfect. It really helps because the denominator is a big old square root. So you just plug it in. Okay. I'm gonna walk around. Those that are trying it here, let me walk around. This is what I got. I have my calculator. Oh, and then I. Yes. I do. Right. And then the conclusion, that's all we have. So 1.85, what was our Z score? 1.96, we did not make it. We were right here. If you want to put a little dot to the ones that you guys did. So the little distribution that you guys wrote, put a little dot right before the 1.96. It was super close, but did not work. So here it is. The two words we need is like this: fail. We failed to reject the null hypothesis. That's the, because we assume it's true in the beginning. Okay, and then we go back. Our claim is the null hypothesis or the alternative hypothesis. What's our claim? Alternative, right? It's a watchdog group said there was a difference, right? So remember, for the alternative, it's either you have support or we don't have support, right? So in this case, there it is. There's not enough support. And we've got to write this down right here. There's not a support at the 5% level of significance. You can stop right here. You can put a period right there. Just that little piece right here. That's what you want. Let me change to a pin so I can put a little dot right there. So there's not enough support at the 5% level of significance. That's it. Okay, cool. Okay, talk to me. How is that? Bad, pretty bad, okay? Not too bad. Not too bad. Okay, cool. Yeah, just the equation itself is kind of big, but that's about it. It's just still chapter 7 stuff all over again. Okay. Next. Are we good there? We good with that one? Cool. All right. And everybody wrote it down. Need to write it down. Okay. So that's it. That's the one example we need from 1.8. Let's 8.1. Thank you. Jump to 8.2. Okay. So if you want to write this in here, so same exact stuff here. We're still looking at means. We're trying to figure the difference between means. We still have independent samples, no problem. Independent samples are still here, except here's our little problem is that we do not know the population standard deviations anymore. This is not a test that's normally done. You can't find national tests or national data that actually includes this, that you can actually run it, right? This is kind of like almost like homegrown tests. Good. So if we don't know the sample standard deviation of the population standard deviations, we have to use the sample standard. And those, instead of Greek letters, they're going to be English letters. All right, I'm going to give you guys the formula for it, and then we'll jump to actually doing it. Okay, we'll have to tell you here now. So there's 2 different formulas. Gee whiz. Okay, 2 different formulas. And here's what we got to think about. If the standard deviations are kind of close together, we use one formula. If the standard deviations are really different from one another, we use a different formula. Okay, good. I think everybody wrote down the title now. Okay, let's go with it. I'm going to give you 2 different formulas. It's all about, actually, it's not standard deviation so much, it's variance. So let's go with it. First formula. Sorry, guys, just writing down a lot here. So if you just put variances are equal. Now, remember, variances are standard deviation without being the square root, right? It's the square of the standard deviation. These guys are equal. We have ourselves it's almost like we're getting the average of the average. That's what we're trying to do. So this little guy, again. Oh yeah, the variance is equal, and then because of that, we're going to use that formula. Yeah, so let me. Okay, once you get that, then we're going to multiply times this. Oh boy, guys, it is kind of not too fun. A little tedious math here to do. And then we probably should write down this as well here. So all that stuff in yellow. So variance are equal. The difference in the variances are going to be that right there. Oh no, because it's just going to be, we will know what those are in the formula itself. So we're gonna, these are the 2 variances, right? And then we're going to give you and I'm going to give you the formula itself. Sorry guys, just a lot of writing here. Go through it. I'll do one example. We're good there. I think almost everybody's ready. All right, sorry guys, a few more writing stuff here. We've got to do both here. So what happens if they're not equal to each other? So the easier formula here. So again, let's write this one in here, and then I'll give you the t value formula for all this here. So this is just to get the bottom. This is just to get the denominator. So we're going to do. So the question usually comes to this, Mr. Rajiv, come on, how come all this work just to get? Because in statistics, we back test and we back test and we back test just to see if it conforms to reality. So this one, instead of adding up the number of values we have or samples and then getting the degrees of freedom by subtracting 2, this one we just use a smaller one. So this one's going to give us the greatest amount of freedom for error. That's what we're looking for. Two examples here, one for the one, the other. Sorry, guys. Yep, there's a tediousness to mathematics, and here it is. All right, we're good. I think chapter 8 has the biggest formulas. Chapter 9 does not have that. chapter 10, at that point, you just plug it into the calculator or an Excel spreadsheet in order to do the math. Because there's so other things happening here. Okay, guys, good? There it is. So this is just the denominator to this formula right here. So let's go. So this is the big formula here. Everything is trying to get into that little guy right here. So it's a t-test. So all we've been doing is we're just trying to figure out how to calculate that piece right there. Good. So variance is the same. We do one way. Variance is different. We do another way for that little piece there. But it's a t-score. Because remember, if we don't know the population standard deviation, it has to be a t-score. All right, so before we go on here, so variances and standard deviations, they are technically the same thing, okay? Except for variances, they don't have the square root next to it. Standard deviations have the square root. Variances don't have the square root. But same calculation. Okay, let's go with it. Okay, we're good there writing that one. Let's go one problem, or actually two problems for this. All right, if you guys want to write in that stuff that's in the box, and I'll just read. I write down that stuff. Or if you want to do it, example one, that's fine too. Just read example one. All right, and then you probably should put alpha level of 0.10. Okay, so here it is. Results of state testing. Mathematics test for random samples of students taught by two different teachers at the same school. So they got the results back and they wanted to see if there's a difference here. Can you conclude if there's a difference in the average math scores for the students? This is like teacher war or something here. Is one teacher better than the other? I don't know. Use the alpha level 0.10. Assume that the populations are normally just. Oh, here it is. Ready. Assume that the populations are normally distributed, and the population variances are not. So once you guys get that, then if we can write a few little things here and tell me if I'm going too fast as well. We're good. They're just long. So I need HO. And HA. Taught by two different teachers at the same time. Can you conclude that there is a difference? Okay, gotcha. There it is. That's all I needed to know. So null hypothesis is mu1 is equal to mu2. This guy is mu1 is not equal to mu2, alternative hypothesis. And that guy is the claim. Okay, you talk to me. Does that make sense so far? All right, then going to the other side, then I also need this guy. I need to know One tail or two-tailed? Left, right, or the same? Again, if there's a difference, right, this has to be a two-tail test, right? Two-tail test here, two-tail test here. If the alpha level is a 0.10, that means we're looking for an alpha level here at the rejection region of alpha divided by 2. And we're looking for a 0.0500. Can you guys give me the T statistic? Oh, yeah, that's right. Hold on, there's a few things happening here. It's a T naught here, and that's a T naught over here, right? Negative and positive. We're good, good. We definitely have to take a break after we finish another problem here. All right, so first things first is variances are the same or not the same? Same. Okay, so once we see that little piece right there, okay, we're going to go into, I'm going to jump a few slides here and there, okay? So on your notes, if the variances are the same, what's your degrees of freedom? What's your DF? Oh, whichever the smaller one is, right? Okay, perfect. Yeah. Smaller of N1 minus 1 and N2 minus 1, right? So your DF is 7. Are we good with 7? All right, on your chart for your T table, looking at DF being 7, can you tell me what's your T value? So two-tail test, alpha level 0.10. And tell me when you think you got it. 1.8, 8 and 5. I go with that. Okay, so I got an answer of negative 1.895. Everybody okay with that one? And a positive 1.895. Good, good. Okay, now we just have to plug it to the formula. So now we have to get our test or our T value itself. So that's where our border ends. Whew. Okay, ready? So I put it all into one. Notice the denominator here. So a few things here. Notice the denominator right here, right? It is this right here. Oh, that's the easier one. Remember that? That's the easier one of the two. And that's actually very similar to what we were doing before, didn't we? In fact, I think that's exactly what we were doing before, the z-score. True, true. Is that the same formula for the z-score? Perfect. Okay, can you guys punch it into your calculator, see if you guys get a 0.922. So this is your second try at it. All right, class, if you guys can go for it, try this on your calculator, see if you guys are 0.922. You can, good. And then let's go with the finish up of it here. And remember, this is going to be very, very similar to the one that you did before. Oh, that's right. And then if you guys can, as we found out as we're going around the room here, you don't need to include the -0, right? You can kind of just forget about this and just kind of make sure you put this in parentheses here, right? So I'm going to keep this in parentheses, forget the 0, just keep that on top. And that becomes, anybody try to get a 0.922? It has not. And is stuck. So a positive 1.895, that's almost close to 2, is that right? Yeah, that's, so definitely we did not get out of the null hypothesis here. Okay, so let's go with right there. So if you draw this, put a little dot right here at 0.922. Cool, and then we failed to reject the null hypothesis. And the question is again, what's our claim? Was our claim the alternative hypothesis or the null hypothesis? I think it was the alternative hypothesis, right? There was a difference between the two math teachers. In this case, there's not enough evidence at the to support the claim. And then put a little pin right here. That's a period right there. So alternative hypothesis, all about support. If the null hypothesis was the claim, then it was reject. Since we're getting close to kind of break time here, so I'm going to do this here. I'm going to run the next problem. And I'm going to put the formulas on here. And if you want to try it yourself in the calculator during break, that's fine. Good. And then we'll come back 10 minutes and then we'll start the next portion here. Okay, we're good. So let's go. I'm going to run through the next example here and let you. I'm going to leave the formula on the screen if you want to try it yourself. We're good, but let's go through it here. So next example, here it is. The manufacturer claims that the average driving cost per mile of sedans is less than that of its competitor. So there's a conducted survey of 30 randomly selected sedans and 32 from the leading competitor. Alpha level 0.05. So I got that one right there. And then it's kind of nice because it's all in one big, nice bracket right here. Okay, results are shown. So there it is for the manufacturer. It was 48 cents per mile with a sample standard deviation of 0.05. And 30 sedans that were driven. The competitor is a little bit higher, yeah, 51 cents per mile. Standard deviation is also a little bit wider. Not by much though, right? 2 cents is not that big of a difference here. So it does say this, just as assume that the population standard deviations or variances are equal. So we're going to go with the other formula. Okay, so they want to prove that their mean driving cost is less than, is that right? Let's see. The cost itself is going to be less than the competitor, right? That's what they want to know, right? So it's cheaper to drive their cars. Cool. Okay, I'm going to run through it a little bit faster. But if you want to take a look at it during break, that's fine. And people that just really need a break, that's fine too. Cool. Okay, based upon that, let's go with it here. So first things first, here's what we should set up. Is that's their claim right here. HA would be their average is less than their competitors, and that's the claim. Right there. We usually write it vertically. They just wrote it horizontally here. Right there. So that means the null hypothesis would be right there. That means theirs is actually greater than or equal to the competitors. Okay, we're assuming that the variance is the same. We good? All right, so since the variance is the same, what we want to do is we want to pull the two variances together as if it's one. And so what we do, we go here, first of all. So degrees of freedom is pulled as well. It's going to be your population for number 1 and number 2 and subtract 2 from it. So that's pulled together. That should be 60. It's 30 plus 32 minus 2. And then it is a left tail test this time with degrees of freedom of 60. And then alpha level 0.05. So if you look at it, that means your rejection regions start with a t value of anything that's less than negative 1.67. I'm going to draw it out. That's fine too. Again, kind of going a little bit faster here. If you want to go back on your table as I'm doing this here, that's fine too. We have this. We have that right there. So and then we have our t value, negative 1.671 from the table. And if you want to look it up on the table, go for it. All right, are we good? Good. Yeah. Okay, and let's see. And here it is. There's kind of two different slides here. So first slide is that computation right there. This is, remember, what variances are not equal. Sorry, guys, to do that. And that's just going to be our denominator. We good? So if you're going to write this in just for now, and I'll go back to this. I'm going to write this one in just for now. Remember, that's our denominator for our t value. Is that right? I'll go back during break here. We got, and then I'll leave this slide up. Just want to be able to finish this up real quick here with you guys. So for now, if you want to write down 0.0155416, And that's going to be this one. If you want to write down for us, it's the sample standard deviation of the difference between x1 and x2. That's what we're looking for. All right, and one last one. Here it is. The last thing we got to do right here. So then it's this piece here. So you use this little number. And I'll put this up during break if you guys need to go back here. I just want to finish it up here for the video here. So there's that. The only thing is, I guess I should do this here. 1 second here. Let me keep, because that's incorrect. Somebody messed up. I'm gonna blame myself, of course. This. That goes away. Okay, that does not help. 1 second here. Go back to get what I want to get it, which is this right here. What that formula over here. Okay. Sorry, let me put this up here. There it is. Much better, right? We're connecting this right here. We're connecting that equation here with that equation right there. So all we did on the previous slide was just to get this little piece called 0.01555416. We needed that denominator. We're pulling our variances together, and hopefully you guys got a negative 1.930 on your calculator. And again, on the calculator, forget about this little 0. It's not going to matter. Forget about that. Leave these in parentheses. You do need these parentheses right here still. And then divide it by, looks like 1, 2, 3, 4, 5, 6, 7. Looks like 7 decimal places. It's a good amount to put in. Okay, and then here it is. Let's go with, do we reject it? Yeah, our t-value was negative 1.671, but our t-value itself was a negative 1.930. Absolutely. So we reject the null hypothesis. Perfect. Okay, so for this car manufacturer, there is enough evidence at the 5% level to support the manufacturer's claim. So yes, their sedans are actually cheaper to drive. Right? Now the question is, are they ugly or not, you know? Do you want to be seen on the street with them? That's the question. There it is. All right. Brains must be filled up with stuff here. So let's take a 10-minute break. I will put the previous screen up if you guys want to copy down the problem itself. Or if you just want to just take a mental break, that's fine too. And we'll come back, we'll do the next 2 sections. So 10 minutes.